functionality can be made to work. And so you can just use your fingers to switch between the different modes and functionality. What's also important, I will give the exact reasons 2 slides later, but I want to mention it at this point already, is that when we do so when we integrate the raw touches, we also assign unique IDs that stay constant over the whole lifetime of this multi-finger cursor. So once you put if you put your 2 fingers down, for example, a 2-finger down event with this unique ID is generated. If you then move your fingers, move events are generated with the same ID until you finally lift your fingers off the surface. Good. So this is sort of a side note. Currently, in the current state, I think we don't have tools that really make much use of this, except for the visual feedback. Maybe that you have seen maybe these blue dots in the videos. This is a feedback layer we added to visualize the touches. But in general, if you want to have more advanced functionality, for example, it might be that depending on the distance between the raw touches within a multi-finger gesture, you want to enable some functionality, or want to change some parameters. Then you need also access to the raw touch input, not just to the multi-finger events. And that's why we also sort of piggyback pointed to the list of all the current touches, hook this up to the events and send this down the queue. And we reuse the custom data field for that, which is, I think, also used for tablet data at the moment, and introduced a new custom type. Okay, so now we come back to the unique ID thing. So now we have touch input in general. We can more or less use one hand because we have decent mappings, and we can, through the multi-finger approach, we can also make legacy functionality usable because we generate mouse events. But if you want to have now concurrent operations with both hands, we need multiple operators to work in parallel, which poses sort of a problem because a lot of operators in Blender are modal operators, which means that normally they are created when an operation is invoked, and while they're active, they sort of swallow all the events until they are either cancelled or finished with the operation. So we had to disable modality. We disabled modality for most of the operations, but then, of course, some of the properties or the modal operators build up on no longer hold. For example, they usually assume that they have like global access and things like that. That while they are in operation, their data does not change and things like that. And you also have to, if you put your other hand in somewhere on the surface, you have to distinguish between the inputs. And that's where the unique IDs come into play again, because we tag all the operations with this ID, so we have a unique and a clear one-to-one mapping over the lifetime of both multi-finger cursors and operations. And this enables us to use several operations in parallel using both hands. Okay, so now we have 2 hands working, but not working together too well. What we also need is we need to exchange some sort of information. For example, the view pinning, or also the object order constraints you saw. They require that, for example, the view control operation modifies the translation operation and vice versa while they are in control. So there we have to come up with a way that the one operation can access and even modify the data of the other operation without breaking it all. So normally they do sort of a, for example, the transform operator does sort of a copy of some important data, creates something that is called a transinfo object or structure, and then works on this over its lifetime. So what we did, but this is maybe the part where this is true, this is really true, and maybe some of the event experts here, the Blender experts, can come up, or probably can come up with better solutions. What we did as sort of a quick solution is we introduced a special flag. So we flagged the objects that are currently under worked on, and also store some pointers to information data, to the operator data, and so operators can look up the objects that are currently modified somehow, and they can also look up what sort of if already, for example, a transformation operation is in progress, so they can exchange the data and can modify each other's data. So this works. You've seen that it works, but probably should be integrated in a more well-grounded manner in the Blender architecture in the future. Okay. So we have another nice figure to summarize. So we have the multi-touch input. At the bottom layer, we have the TUIO interface, which together with multi-finger mappings and the IDs enables single-hand usage. Operator parallelization enables individual bimanual control. The operator communication enables concerted bimanual control. And the context info raw touch data enables us to build truly multi-touch enabled functionality, and to do this in an incremental manner, bit by bit, starting from the legacy functionality, and of course into Blender. Okay, the operator communication is I mean Blender operators. I mean, for example, that the translation operator or the transform operator has to exchange the current state of the object with the view control operator, for example, the view rotate operator, things like that. Okay, so this already brings me to the conclusion of our talk. Some looking back, summarizing lessons learned. Well, first of all, it was sort of a success. You've seen that we integrated multi-touch into our own private build of Blender already, and it works in principle. So Blender can be multi-touch enabled, which we think could be a real benefit. Blender could be one of the first tools to actually support multi-touch compared also to other 3D tools. We found in various experiments that direct touch and bimanual control in particular is very beneficial to 3D modeling and animation. You have this direct grab and act approach. You can have more efficient workflows with 2 dedicated hands and more degrees of freedom with concurrent bimanual control. Of course, there's no one solution fits all. So it's not the idea to replace everything, every interface like mouse or special cursors or tablets or whatever. It's more intended to complement and to enhance the possibilities with new input. And last but not least, while this is certainly not the main target, or might not be the main target for serious applications, multi-touch definitely significantly increases the fun factor and the overall experience, which we think is also an important issue, especially in comparison to other software packages. You just have to ask Apple about it. So you see, this is something that is important. So our plans for the future. Well, this is just the start, of course. Still, it is fairly simple, but already we are quite proud of it. There are many more ways, different ways to map fingers. There are more advanced mappings you can come up with. So this is just the start, especially the operator communication, things like that. We still have to work out a bit, so more significant changes might be necessary in the future. And it would be nice if we could somehow bring a bit of the functionality maybe to the current branch of the code base and proceed from here. We'd really like to work together with you guys to bring in some multi-touch functionality into mainstream Blender. Okay, thank you.
Thank you, very, very interesting session. I think that if people have questions, it would be better to do that outside of this room, because we really need to continue with the next session. We are running a little bit late. Yeah, everything is interesting, right? So please, for the next session, Jiri with verse 2 new design specification for the verse protocol. Okay, so the next session, Jiri Hnidek with a version of new version for verse. Yes?
When is your compilation or compiling and coding workshop? Is it?
In 20 minutes about.
So in the middle of Jiri's?
Yeah, no, we'll see.
Okay. Good afternoon. First of all, I would like to introduce myself. I'm Jiri Hnidek. I come from Czech Republic, and I'm PhD student at Technical University in Liberec. So what is it verse? I would like to do you some introduction and history of this network protocol. So it should be and could be used for real-time sharing of 2D or 3D data. So you can upload your data to server. And if some other client is connected to this verse server, then you can do real-time sharing of this data. So the author of original verse protocol is Eskil Stenberg. He's present here. And I forgot about Emil. He's co-author, I would say. This protocol was supported or developed mostly during Universe Consortium period. It was supported from European Union. So how am I involved in this project? Theme of my PhD studies is network protocol for graphical applications. And I began my studies with implementation of Wars protocol to Blender. And my first idea was this, that I will integrate it to the Blender, test it, find some weak parts, improve these weak parts, and everybody will be happy, and I receive PhD title. I did this simple implementation of Wars to the Blender, but I found too many weak parts in Wars protocol, and I had decision to rewrite the specification of this protocol from the storage and implementation too, because it was simpler for me. How many of you have ever tried to use Blender with Wars integration? So, how many of you have never heard about it? So, some of you, okay. So I will try to show some demonstration.
You can also use this microphone, it's easier for you.
Is it working?
Yeah?
No.
You don't have to be very close. It works on this distance. Can you turn this one on?
Hello, 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 yeah?
Yeah?
Thank you. Thanks. I use multi-head configuration, so it will be a little bit complicated for me. I will connect to Wars server at the first time. And if I'm connected to Wars server, then I can share, for example, this cube between two instances of Blender. And when I change something here, then this is automatically sent to the Wars server, and this client, which is subscribed to this cube, is receiving information about this cube, about position and about data. So that's it. So what was the weak parts of original Wars protocol? From my point of view, it was that Wars server and Wars client have to use only one UDP socket. It is a problem because UDP socket has only about 100 kilobytes for buffer, and when you don't read data from this socket enough fast, then this OS layer can drop packets and informations. So it's probably the biggest problem in implementation. The second problematic part is security, First of all, it isn't described in specification anywhere. There is some short description, but if you would like to recreate this implementation in some different programming language, then it is problematic. So there is something. The next problematic part is that the handshake isn't aware of man-in-the-middle attack, so you can do attack on this protocol. And it uses our RSA implementation, and it could be improved. It used some recent mechanism because it tried to be a reliable or semi-reliable protocol, but this recent mechanism could be improved too. The API of old verse has many weak parts. I will talk about it later, and the transmission of data could be improved too, because there are many duplicities when you send, for example, many vertices or many colors of vertices. And it doesn't use path MTU discovery, so when you are connected to the verse server at the local host, then in this case packets are fragmented, unnecessary. So I will talk about network protocol at first time, then I will talk about data model, then API, and finally about implementation. So when you want to create new network protocol, then you have to create some requirements on this protocol. So it has to be, the new verse protocol has to be again real-time protocol. So we require low latencies of received data, and we want to use it for sharing. So it means it has to be reliable or semi-reliable. This protocol has to be robust. It is important part, very important part. Security, because when we want to share some data on server, then we have to authenticate, and when we send this username and password, then we have to send it in secret channel. And of course, it is protocol of application layer. The original verse protocol uses UDP at the transport layer, and I did some research if it could be possible to use some other transport protocol. There are probably 3 other possibilities, but all of these transport protocol I found not useful for my approach, because TCP protocol, it's stream and reliable protocol, but it tried to resend all data in in the right order. So it means that when some packet is lost, then receiving data to your application at application layer is stopped until the lost packet is resent. Yeah, so the data are received to you, but you can use it because operating system blocks receiving or receiving these data to your application until the lost packet is retransmitted. Yeah? The similar problem is with SCTP protocol. It is a message-based protocol, so there is no need to wait to retransmission of lost message, but it leads in similar high delays as TCP. DCCP is a modern datagram protocol. It has congestion control implemented in itself. It has some handshake, teardown, but the problem of DCCP and SCTP is that it's not widely used at Windows operating system, and most of network equipments like switches and routers doesn't support it too. When we want to create a new network protocol, then we have to do it in several ways. At the first time, we should create a new specification with most of details. Then we have to verify this specification. We have to verify that there is no deadlocks, no live logs, and this is usually done in Promela programming language and Spin program. It means that you create some high-level model of your specification, and then you prove that it will work in all cases. When you verify that your specification is right, you should do the implementation. After implementation, you should do some testing, and in ideal world, you should do conformance testing. It means that implementation works in the same way as your high-level model from the second step. And of course, network protocol should be something dynamic. So if you are using it, you usually find that it has some weak parts, and you should then recreate specification, verification again, so it's life cycle. So what are the main features of Nuverse protocol? It uses TCP for user authentication and a negotiation of new UDP connection and cookies and so on. Our data exchange is done at the UDP socket. It has new handshake and it uses path MTU and teardown. It has new recent mechanism and it could use DTLS for encryption of data. What is also new is that the commands are with variable length, and it could lead to compression of data. All Verse protocol uses commands with fixed length, and it usually leads to inefficient transmission of data. What is work in progress is congestion control and scheduling of data. So what is basic principle of recent mechanism? Let's consider this situation. There is some client, and this client sends position of this bouncing ball. It sends this information every frame, and every packet has some ID, and when the packet with ID 32 is lost,